The timeless kingdom. Our perception of time is often framed by the length of a human life. A century, perhaps, if one is fortunate. But here, on this extraordinary planet, there are creatures for whom a century is but a fleeting moment. Life, in its endless ingenuity, has found ways to stretch existence far beyond our comprehension, crafting beings that witness the slow, inexorable turning of ages. From the crushing, silent depths of the ocean to the sun-drenched solitude of remote islands. These ancient survivors carry the secrets of longevity within their very cells. They are the quiet custodians of Earth's deep history. Join me as we journey across the globe to uncover these marvels of endurance. We will explore the remarkable adaptations and the unique environments that allow these animals to outlive us all, sometimes by millennia. These are not tales of myth or legend, but scientifically verified stories. We will look into the eyes of sharks that swam in the age of Shakespeare and touch the shells of clams that were living when the Ming Dynasty reigned. This exploration is more than a list. It is a lesson in resilience, adaptation, and the breathtaking scope of the natural world. By understanding how these creatures achieve such lifespans, we gain a deeper appreciation for the delicate web of life. Let us now begin our countdown and meet the 10 ageless animals that defy the very concept of time as we know it. The immortal jellyfish, Turritopsis dohrnii. Our journey into the realm of the ageless begins not with a colossal beast, but with a creature no bigger than my little fingernail. Here in the temperate waters, here in the tropical waters floats the immortal jellyfish, Turritopsis dohrnii. Its name hints at a power that seems to belong to fiction, but its reality is a biological marvel. It possesses an ability that has captivated scientists, the capacity to reverse its own life cycle, effectively cheating death from old age. When faced with environmental stress, starvation, physical damage, or a sudden change in water temperature, the mature medusa, the familiar bell-shaped form of the jellyfish, does something extraordinary. Instead of succumbing to the pressure and perishing, it initiates a process of transdifferentiation. Its cells, once specialized for their roles in the adult body, begin to transform, reverting to an earlier state of being. This is cellular alchemy of the highest order. The jellyfish's body folds in on itself and the life cycle begins anew. The ocean quahog clam, Arctica islandica. From the dynamic cyclical life of a jellyfish, we now turn to a creature defined by stillness and immense patience. We travel to the cold, dark waters of the North Atlantic, to the seabed where the ocean quahog lies half buried in the sand. This unassuming bivalve holds the record for the longest-living non-colonial animal, a true Methuselah. In 2006, a specimen dredged off Iceland stunned scientists. Initially aged around 405 years, it was nicknamed Ming, born during the Ming Dynasty. Later, more precise analysis revealed it was 507 years old. This tiny clam had been filtering ocean currents since Leonardo da Vinci painted the Mona Lisa. It lived through centuries of human history, wars, revolutions, and the dawn of the Industrial Age. Its secret, an exceptionally slow metabolism. Its life story is recorded on its shell. Ming's tale ends in tragedy. To discover its age, the clam was frozen and its shell opened, ending its half-millennium life. The Greenland shark, Somniosus microcephalus. We remain in the cold, forbidding waters North Atlantic and the Arctic Oceans to meet our next ancient mariner, the Greenland shark. This is an animal shrouded in mystery, a slow-moving giant that patrols the crushing, lightless depths. Growing up to 24 feet long, it is one of the largest carnivorous sharks in the world. Yet it moves with an eerie, almost lazy grace, conserving every ounce of energy in its frigid habitat. For centuries, the lifespan of the Greenland shark was a complete enigma. Then, a groundbreaking study provided a stunning revelation. By using radiocarbon dating on the proteins within the shark's eye lens, a part of the body that grows continuously throughout its life without shedding cells, scientists were able to unlock its age. The results were staggering. The oldest shark in the study was estimated to be at least 272 years old, and possibly as old as 512 years. This makes it the longest living vertebrate on Earth. Imagine a creature swimming in the ocean today that was born before the United States declared its independence. The bowhead whale, Balena mysticetus. We now ascend from the depths to the sunlit, icy surface of the Arctic, the realm of a true titan of longevity, the bowhead whale. This magnificent creature, with its enormous arching jaw that gives it its name, is a testament to mammalian endurance. While most large mammals live for a few decades, the bowhead whale shatters these expectations, with evidence suggesting lifespans over 200 years. For a long time, ages were estimated traditionally, but the most convincing proof was both ingenious and grim. Old unexploded harpoon tips, stone weapon fragments have been found embedded deep in blubber. Some artifacts date to the late 1800s. A whale harvested in 2007 contained a bomb lance fragment made around 1890, showing it lived well over a century after being struck. Longevity links to remarkable genetic adaptations. The black coral, Leopathes sp. Our quest for longevity now takes us deep beneath the waves, into a world of perpetual twilight. Here we find something that blurs the line between an individual organism and a sprawling ancient community. This is the realm of black coral. While the name might conjure images of dark stony structures, these are living animals, colonial organisms related to sea anemones and jellyfish. And some of these colonies are among the oldest living things on our planet. These are not the corals of shallow, sunlit reefs. Black corals are found in the deep sea, often thousands of feet down, where light is scarce and life moves at an imperceptibly slow pace. They form intricate, tree-like structures, building their skeletons layer by layer over immense timescales. It is this slow, patient growth in a stable, cold environment that allows them to achieve their extraordinary ages. It is crucial to understand that we are talking about the age of the colony, not of a single tiny animal. The coral structure is made up of thousands of individual, genetically identical polyps. These polyps live, reproduce asexually to expand the colony, and die, being constantly replaced over time. Off the coast of Hawaii, specimens of the genus Leopathes have been dated to be more than 4,265 years old. The glass sponge, Monorhaphis chuni. We descend even further into the abyss to depths where the pressure is immense and sunlight has never reached. Here, rooted in the soft sediment of the seafloor, live the glass sponges. These are creatures of profound simplicity and astonishing antiquity. Lacking organs, muscles, or a nervous system, they are among the most primitive of multicellular animals. Yet in this simplicity, they have found a pathway to lifespans that can be measured not in centuries but in millennia. Glass sponges construct their skeletons from silica, the same basic component of glass. They extract silicic acid from the seawater and biocatalytically shape it into intricate lattices of glassy spicules. By analyzing the composition of these layers, scientists have estimated the age of some of these giant spicules to be as much as 11,000 years old, plus or minus a few thousand years. The red sea urchin, Mesocentrotus franciscanus. We now rise from the abyssal depths to the vibrant, turbulent waters of the Pacific coast of North America. Clinging to the rocky seafloor amidst swaying kelp forests, we find the red sea urchin. This spiny, globular creature, a familiar sight to many divers, hides a remarkable secret. It is a master of defying the aging process. While many of its sea urchin relatives live for only a few years, the red sea urchin can live for more than 200 years with no discernible signs of growing old. This phenomenon is known as negligible senescence. Essentially, a 100-year-old red sea urchin can be just as healthy and reproductively capable as a 10-year-old one. They do not appear to suffer from age-related decline. They continue to grow, albeit very slowly, throughout their lives, and older individuals are often just as fertile as their younger counterparts. They don't die of old age. Their lives are typically ended by predators, disease, being harvested by fishermen. Determining the age of a creature with no outward signs of aging presents a challenge. The rough-eye rockfish, Sebastes alucianus. Our journey continues in the cold, deep waters of the North Pacific, from the coasts of Japan to California. Here, suspended in the darkness, lives the rough-eye rockfish. Named for the small, harmless spines below its large eyes, this fish is a member of a genus renowned for its longevity. While many fish live for just a handful of years, the rough-eye rockfish can reach an incredible age, with the oldest recorded individual living to be 205 years old. These fish lead a slow and deliberate existence. They inhabit depths of up to 2,500 feet, a world of high pressure, low temperatures, and limited light. In this stable, cold environment, their metabolic rate is greatly reduced. This live, slow, die-old strategy is common among deep-sea dwellers and is the primary reason for their extended lifespans. The life of a rough-eye rockfish is one of quiet waiting. They are ambush predators. often remaining nearly motionless for long periods. So how do we know the age of a 200-year-old fish? The answer lies within its head, in small calcium carbonate structures called otoliths or earstones. By carefully slicing a thin section of the otolith and examining it under a microscope, scientists can count these annual rings, or annuli, to determine the fish's age with a high degree of precision. The giant tortoise, Galapagos, and Aldabra. We leave the cold ocean depths and travel to two sun-drenched, isolated sanctuaries, the Galapagos Islands in the Pacific, the Aldabra Atoll in the Indian Ocean. Here, on land, we meet one of the most iconic symbols of longevity, the giant tortoise. These gentle, colossal reptiles move through their world with a serene deliberation, as if time itself is of little concern. And for them, it isn't. They are among the longest-living land animals, regularly surpassing 150 years of age. Their long lives are well documented through famous individuals who became beloved icons. Harriet, a Galapagos tortoise collected by Charles Darwin himself, lived at a zoo in Australia until her death in 2006, at an estimated age of 176. Adwaita, an Aldabra giant tortoise who lived in a Kolkata zoo, was believed to be around 255 years old when he died in 2006. The secret to the tortoise's longevity is a classic combination of factors. First is their incredibly slow metabolism. As cold-blooded reptiles, their energy needs are low, and their slow, grazing lifestyle is exceptionally energy efficient. Their island homes also play a crucial role. Isolated from the mainland, these tortoises evolved in environments with few, if any, natural predators once they reached adulthood. Today, thanks to intensive conservation efforts, these ancient, peaceful giants are slowly recovering, continuing their slow march through time as living monuments to endurance and survival. The freshwater pearl mussel, Margaritifera margaritifera. For our final ageless animal, we return to the water, to the cool, clear, fast-flowing rivers of the Northern Hemisphere. Here, partially buried in the gravel beds, lives the freshwater pearl mussel. This dark-shelled bivalve may seem unremarkable at first, but it's another of nature's quiet long livers, capable of reaching ages between 130 and 250 years. A mussel living today in a Scottish river could have been born during the Napoleonic Wars. Like the ocean quahog we met earlier, its longevity is a product of its environment and a very slow metabolism. The cold, oxygen-rich water of its pristine river habitat slows all its life processes to a crawl. It grows incredibly slowly, less than a millimeter per year once it reaches adulthood. It sits on the riverbed, filtering tiny organic particles from the water. The life cycle of this mussel is fascinating and complex, relying on a unique partnership. In their larval stage, known as glochidia, the microscopic mussels must attach to the gills of a specific host fish, typically a young salmon. Their fight for survival is a silent, urgent plea for the preservation of our planet's precious freshwater ecosystems. Echoes of deep time. From the biological immortality of a tiny jellyfish to the millennial existence of a deep-sea sponge, we have journeyed through a world that operates on a timescale far grander than our own. These 10 creatures are not simply curiosities. They are living libraries, carrying within them the environmental records of centuries and the genetic secrets of healthy aging. They show us that life, in its boundless creativity, has explored countless strategies to endure, from the slow, patient stillness of a clam to the constant cellular renewal of a coral colony. Their extraordinary longevity is a profound reminder of the stability and purity their habitats once offered. Today, many of these ancient survivors face their greatest threat, a world changing faster than their slow-paced lives can adapt to. Their continued existence depends entirely on our wisdom and our willingness to protect these unique and precious corners of the natural world. The story of our planet is written not only in rock and ice, but in the heartbeats of its oldest inhabitants.